Welcome to Civil Engineering Topics. In today's video, we'll explore one of the most important topics in open channel flow types of open channel flows. We'll break it down step by step based on different criteria. By the end, you'll clearly understand how to classify open channel flows like steady and unsteady, uniform and non-uniform, gradually varied flow and rapidly varied flow, and more. So, let's dive right in. Classification of open channel flow. Open channel flows can be classified based on four main criteria. Based on time, flows are classified as steady flow and unsteady flow. When flow parameters depth, velocity, discharge do not change with time, it is called as steady flow. Example of steady flow: water flowing in a canal with constant discharge. When flow parameters depth, velocity, discharge change with time, it is called as unsteady flow. Example: river during flood, reservoir releasing water. Next criteria is space. Based on space, uniform and non-uniform flows are classified. If the flow properties such as depth of flow in an open channel remains constant along the length of the channel, the flow is said to be uniform. Example: long prismatic canal with constant slope and discharge. And if the flow properties such as depth of flow in an open channel vary along the length of the channel, the flow is said to be non-uniform. Example: flow approaching a dam or a sluice gate. Third criteria is variation of depth with distance. Based on variation of depth with distance, open channel flows are classified as gradually varied flow, rapidly varied flow, and spatially varied flow. If depth of flow changes gradually over a long distance along the length of channel, such that curvature of free surface is mild, then flow is called as gradually varied flow, or GVF. Flow at upstream side of sluice gate is an example of GVF. If the curvature in a varied flow is large and the depth changes appreciably over short length, such flow is rapidly varied flow, or RVF. Flow at downstream side of sluice gate and hydraulic jump are the examples of RVF. Next one is spatially varied flow, or SVF. It is the type of open channel flow in which the discharge changes along the length of the channel. This means discharge is not constant. It varies with distance. This variation happens because of addition or removal of water along the channel. Spillway chute with side weirs, irrigation canals with multiple outlets, etc. are the examples of SVF. Next criteria is based on Froude number. Using Froude number, flows are classified as subcritical, critical, and supercritical. What is Froude number? The ratio of inertia force to gravity force is called the Froude number. If the Froude number is less than 1, the flow is called subcritical or streaming or tranquil. Flow is dominated by gravity. Example of this flow is deep and slow river flow. And if the Froude number is equal to 1, then flow is called critical. In this critical flow, velocity of flow is equal to wave celerity, or velocity of small surface waves. This flow marks transition between subcritical and supercritical. If the Froude number is more than 1, then flow is called supercritical or shooting flow or torrential flow. This flow is dominated by inertia. Steep channels and spillway flow are the examples of supercritical flow. And the last criteria is based on Reynolds number. In an open channel flow, Reynolds number is used to differentiate between the laminar, transitional, and turbulent flow. What is Reynolds number? It is the ratio of inertia force to viscous force in a fluid flow. If Reynolds number is less than 500, then flow is called as laminar. In laminar flow, water particles move in smooth layers, no mixing, and velocity distribution is parabolic. This flow is rare in natural channels, may occur in laboratory models or in very slow seepage flows. If Reynolds number is between 500 and 2000, then flow is called as transitional. In transitional flow, flow is unstable, partly laminar and partly turbulent. This flow is not commonly encountered in practice. If Reynolds number is more than 2000, then flow is called as turbulent. In turbulent flow, flow has eddies, irregular fluctuations, and mixing. This flow is most common in natural streams, rivers, and man-made canals. So that's all about today's topic. I hope this video helped you understand it clearly. If you found it useful, don't forget to like, share, and subscribe to Civil Engineering Topics for more civil engineering concepts explained in a simple way. Drop your doubts or suggestions in the comments below. I'll be happy to help. See you in the next video. Until then, keep learning and keep building.